Chapter 6.2, the natural base e. So far you have in your study of mathematics, you have worked with special numbers such as pi and I. Another special number is called the natural base and it's denoted by e. The natural base e is irrational, so you cannot find its exact value. Exploration we are going to do for natural base is you need to consider this expression 1 plus 1 over x to the power x. So whatever goes here, it's the same on the top. As x increases, the value of this expression approaches the value of e. We are going to complete this table right here. 10 to the power 1 means just 10. 10 to the power 2 is 100. 10 to the power 3 means 1000. 10 to the power 4, 10,000, and so on. Here we are going to apply this method and we are going to put x as 10. So we are going to have here is 1 plus 1 over 10 to the power x. So what we're going to get here is 1.1 to the power 10, and that's going to give us 2.593 Next we are going to put 100 for x, so you're going to get here is 1 over 100 to the power 100, and that when you solve you're going to get here is 1 plus 0.1 to the power 100, and your answer is 2.70481. Similarly, when you put 1000 for x, you're going to get your answer as 2.71692. So the rest of the answers for 10 to the power 4, you get this answer. For 10 to the power 5, you get this answer, and 10 to the power 6 is this. You're going to use the calculator and find these answers. The natural base is used in a variety of real-life applications. One application is continuously compounded interest. As the frequency of compounding increases, the formula for compound interest is A equals P 1 plus R over T to the power NT. Approximate the formula for continuous compounding A P times e to the power RT, because now this part of this one is called e. So you got ERT. This can be done with the calculator. Let P is 1000, R equals 6%, and T is 10. Now we are going to solve this with this formula. With this formula, we're going to solve the compound interest when it's counted quarterly, when n equals 4. What should be the amount? So when n equals 4, so you're going to put 1000 here, 1 plus 0.06 r divided by 4 times 10. What you're going to get here is, you're going to get here A equals 1000, 1 plus 0.0015 or 15 to the power 40. And when you're going to use the calculator and solve it, you're going to get 1814 decimal 0.2. And when you're going to use the next one, when you're going to count the interest monthly, you're going to use n as 12. So 0.006 divided by 4 to the power 40, and the answer for this one you're going to get 1819.40. And next you're going to use weekly. Weekly means that you're going to use n as 52. Formula is the same, and then you're going to use n as 52. So 52 times 10 is going to be 520. For this, answer is going to be 1821.49. And next is daily. If you're using daily, you're going to use n as 365, and that is going to be 365, and on the top you're going to get is 3650. For that, answer is going to be 1822.03. And if the interest is counted continuous, then you're going to use this formula right here. And answer for that one is 1822.12. Continuously compound interest. When interest is compounded continuously, the amount A is an account after T years is given by the formula A equals P e to the power R T, where P is the principal, R is annual interest rate expressed as decimal.